So hi guys, welcome back to my YouTube channel, and today I'm up with the next question of the lead code, which is median of a data stream. So let's get started with this question, right? So basically in this question what we are given is we'll be given a stream of integers like in the format of 1, 1, 0 and what we can say 102, 1024, or we could be given stream like 10243, something like this, right? So we need to figure out the median of the numbers whenever a number is being added to a stream, right? So what is the median of this number when we have only one? The answer is pretty simple, it's 1. And what is the median of both of these numbers, 0 and 1? 0.5, because 0.5 is the middle value amongst those. But before that we need to sort the array in the increasing order, right? So my sorted version is 0, 1. And now let's talk about this example 102. So what would be my median? It would be 1, and the sorted order of this stream is 0, 1, 2. So now talking about 1024, so the median would be 1 plus 2 divided by 2, which is equal to 1.5, and the sorted order of this is 0, 1, 2 and 4. Okay, and now talking about this stream, so my median over here would have been 2, and the sorted order would have been 1, 2, 0, 1, 2, 3 and 4, right? So we are done with this knowledge. So I think everyone must be knowing the way in which we calculate the median of two numbers, right? So suppose if I have odd number of numbers in my list, right? So then my median is at n by 2th position, okay? And if I have even number of elements in my list, then I have to calculate the sum of the the average of the elements present at n by 2th and n by 2 plus 1's place, right? So that's what the question states. Okay, since we are already given that we have to add some number and then we have to compute its median, so let's think of storing this stream in an array, right? Suppose I think of storing this stream in an array. Okay, since now let's go through the question. So what is median? It's the middle value in an ordered integer list, right? So one thing for sure, we are clear that we have to order the list, okay? And if the size of the list is even, there are no middle values, the median is a mean of two middle values. As we have already discussed, that if we have a even length string, we will basically compute the sum average of n by 2th and n by 2 plus 1th element, okay? That's what the thing. So we have to implement the median finder class, where median finder initializes the median object, and void add num, it basically adds integer to the data stream, as I have been adding integer at each and every step, and double, and we have a function double find median, which will return the median of all elements so far, and answers within 10 raised to power minus 5 of the actual will be accepted. Okay, that's something different. So yeah, since I'm getting some floating values in these examples, so we have to take a float value for finding out the integer. Okay, so it's so after reading the question, you all have been thinking, yeah, it's pretty simple. We can basically store this stream, because since we are not required to delete anything, so we can easily store this stream in some vector. Yeah, let me take that and take some vector, and we can continuously push at each and every step and then sort that array, and then we will find out the median by computing the length first, and then we will find out the median. Okay, so it sounds cool. Okay, so let's push 1 in a vector. So at this point my median is 1, as already discussed, and then afterwards I get 0 and 1 and 0, 1 and 0, and then I will sort this list in the ascending order, right, which is 0, 1. And then what I will do, I will find the since the size of this list is even length, the size of this list is 2, so I will basically compute 0 plus 1 divided by 2, which is equal to 1.5. Okay, so let's discuss the steps. Let's discuss the time complexity involved over here, because we have already discussed these examples, so we can move pretty forward to the time complexity. Okay, so storing the elements in a vector, I don't think that it okay, so let's discuss time complexity. So the time complexity in this case, what does it involve? First of all, we are basically sorting this given stream which we already have, which is n log n. Okay, right? And then what we are doing, we are basically finding the length. Okay, so computing the size function. Okay, so the complexity of size function, which turns out to be order of 1. Okay, it's pretty simple, because at each and every step we have to calculate the size of the array, right? And then we are computing the median, which is again a O of 1 operation. Okay, and what is my space complexity in this case? Because we are using an internal function, so there would be some memory involved due to this, and the space complexity, obviously it's O of n, because we are storing all the n elements. Yeah, we can't, if we want we can ignore it as well, because if we are, suppose we are having a data stream, so it's an obvious common sense to know that we will be storing this anywhere, right? So but I am still taking it because we are actually using this space. Okay, so everything seems to be fine, and I think that this will actually like work, but there is a but in this. Like, see, if you have at some point like 10 raised to power 9 elements in your array, like at some point, suppose you have a very big list which comprises of 10 raised to power 9 elements, and your 10 raised to power 9 minus 1 is the last element. Suppose I'm just assuming it, not in the real. Yeah, if you get a list something like this, do you think your solution of n log n will actually work? Will you be able to sort this list in the real time and then compute the size and then the median? The answer is no. So, and moreover, after doing this approach, what I have basically thought is, okay, so this is the worst case that I could have discussed. Yeah, so now let's get to the question itself. Okay, so if you would have been asked this question in the interview, you would have given this straightforward approach to the interviewer, and yeah, of course from your end you would be having a satisfaction that you have done the question, but still your interviewer would not be happy with this, since I've already discussed that test case, that if suppose you have 10 raised to power 9 elements in your array, then how will you actually implement this solution, right? It will take a lot of time and a lot of and a lot of time, and your solution will run into time limit exceeded. So yeah, since we are already, so what is n log n? We are basically sorting the array in increasing order, right? So let me just write down one stream of integers, 1 0 2 4 3 and 5 and 6. Okay, so and more, so we are using this n log n to basically sort this string. So why not we store all of this string in such a way that we already have a sorted version of this string beforehand, before computing a median only, we are having a sorted version, or at the same time whenever we are inserting, we sort this list and place the elements at its correct position. Like suppose if at this instance I'll be given some integer 7, maybe if I can find out some data structure where I can store these elements effectively in such a way that all my elements, that at the time of insertion only, that my elements get sorted in increasing order. So yeah, we do have an answer to this. Wait, I think I'm going a little bit fast, right? So what we have discussed till now. So I have discussed that the time complexity of the above solution which we have discussed is n log n, and yeah, because we don't have to delete any elements from this list, because only we are given to implement two functions, that is add and find median. So forget about that we will ever delete it. So let's just think that sorting at every step doesn't make really a good sense, right? So suppose if you are getting a integer from your string, like I have got 6 over here. If my list at this point would have already been sorted, would it be easier to insert 6? Like I already sort my list till here, okay, and I get 6 to be inserted in this list. Is it easier to insert 6 in a sorted list and to find the median? Definitely yes, of course. Okay, so what we need to figure it out at this point, we need to figure out some data structure where we can store the list in the sorted order. Okay, that's cool. So storing the list in some sorted order means we have to find a data structure where things are getting sorted upon insertion. So at this point we can think of using a heap. Because in a heap we can either store our elements in increasing order or in decreasing order. Like if I store all of these elements in my min heap, so what would I get? 0 1 2 3 4 5 and 6. So I think this structure basically gives an insight that all my elements are stored in some sorted order, in some increasing fashion. Okay, if I think of storing my elements in some max heap, so what would have been? It would have been something like this. 6 4 5 1 2 and then 3. 0 and 1 2 and 3. Okay, so my max heap would have been something like this. So from the max heap we can see these elements are in increasing order, in some in some decreasing fashion, right? So at top of this heap we would always be getting the maximum element in the max heap, and in the min heap we would be getting a minimum element at the top, right? So we are done with this. So we can happily say that we can either choose a min heap or a max heap. But wait, since we have to compute the median, and in the previous solution we are computing our median in O of 1. Okay, so we have to improvise the solution for using the heaps in such a way that we would be able to calculate our median in O of 1 time complexity, right? So how to achieve it? So what is median? Let's get to the basic definition of the median. Okay, so what is median? It's basically mid of two values, right? Middle value. Okay, so in this list, since this list is of size 7, so my middle value is 3. And if I would have been having a list, the previous version which I was talking, wait, so what would have been a middle value over here? It's 2 and 3, right? So even in some odd length or in some even length, like in any sort of stream, we are having the middle values. We have to work on the middle values, right? So what I'm thinking of is that how to get these middle values on the top of my heap, right? Either in min heap or in max heap, right? So what I'm thinking of is, because I have to compute my median in O of 1 time complexity, so I'm thinking of using my middle values on the top of the heap, because whenever we try to access the top element either in min heap or in max heap, we get that element in O of 1 time complexity. Okay, because what we are doing, we have to simply use a function like pq.top, and it will basically get the top element of the heap. So fair enough. So yeah, since I already told that I want to get my middle values on the top of my heap, so what I can do, I can basically so what comes to my mind is, I can basically divide my array into two parts, because by dividing this stream into two parts, it will actually help me get the middle values on top. So to get the middle values on top, so what all combinations we can have? So I told that I will divide this into two halves. It means I will be using two heaps, right? So either I can use a min heap, min max, or max min, or max max. Okay, so I have so even in this case also, I can divide my stream into two parts. Okay, that's great. So suppose I've told that I will divide in two parts, and I will try to get my maximum values on the top so that I can find my median in O of 1 time, right? So let's explore all of these 4 options. Okay, so suppose I try to compute using 2 min heaps. Okay, so let me just draw my array. I will use an even length at this time, because it would have in other case I would be using an odd length. So suppose I try to compute using 2 min heaps. I've already told that I will divide my array in such a way. So first option, like taking 2 min heaps. Okay, so how would have my solution been looking like? 0, 1, 2, 3, 4 and 5, and over here it would have been 0, 1, 2, 3 and yeah, we are done, and 4, 5 and 6. So, and now explore the second option, max min heap. So before exploring the second one, let's just see. So whenever we use one min heap, two min heaps, in the second part we are able to successfully get our middle value on the top, right? So I think it sounds pretty clear that in one of the parts, like the one which is having greater numbers, the part in which we are having all the greater numbers, we will store that part in the min heap. Okay, because we have to fetch the middle, because we have to fetch a value in that part which is the lowest among them and is at the middle position, right? So amongst 0, 1, 2, 3, 4, 5, 3 is the higher value which is at the middle position in the bunch of 3, 4, 5, right? So I am able to easily get my middle value on the top in this min heap, right? In the second part where all my larger integers are where all of my integers with greater values are stored, right? So the part of the stream which contains larger values, I'll be storing that part in my min heap. So it sounds clear. So my second half which contains all the elements which are greater, I will store them in min heap. And similar is the case with the second problem where I have the odd length. So here I am successfully getting 4, which is the middle value on the top. See why I am saying 4 as being middle, because n by 2th and n by 2 plus 1th element, they are almost at the middle. So right, we have to basically, so what we have, so I think for one query we have got the answer, that the part in which the part of the stream where we are having all the larger values, we will store that part in min heap, right? So the part part 2 will always be stored in min heap because it comprises of larger values. Okay, so what we can see, that amongst our two options we can simply cross out second and fourth, because if we'll be using max heap, my larger element would have been on the top. Okay, so we are only left with one option, max and min heap. So before moving to that, so let's check the scenario of the first part. So in this heap 0, 1, 2, are we able to get 2 on the top? The answer is no. So we are not using min heap over the first part, because using min heap over the first part will actually give us the smallest value of the stream, right? So we will not be using min heap in the first part. So this option of min has been deleted. So let's go to the final option that we are left. So let's use a max heap and a min heap. So if I'll be using max heap 0, 1, 2 and a min heap 3, 4, 5, and now it comes out to be 3, 1, 2 and then 0, and it comes out to be 4, 5 and 6. So as I've already told that in the second part of the stream, we are successfully getting the middle values on the top. And in this case we have 3 and 4, right? Fair enough. So what is the middle value? So what is the largest value amongst the first part? It is 2 in this case and 3 in this case. Yeah, fair enough. So basically the reason to use max heap in the first part is clear, because in the first part we are having all the smaller values and we have to get a value which is largest among them. See, amongst 0, 1, 2, the largest value is 2, and amongst 0, 1, 2, 3, the largest value is 3. So storing this part in the max heap will actually help us to know the largest value amongst the smallest ones. So these are smallest, and amongst them the largest is 3. So we are able to successfully determine our choice that max heap and min heap combination will work for us. And in this case, so even if we look at the stream, so the median of this stream comes out to be 3 plus 2 divided by 2, which is 2.5. So if we try to fetch the top elements of both of these, 2 and 3, so 3 plus 2 divided by 2, it comes out to be 2.5. And in this case 4 and 3, since the size of the heap is since we are having odd number of elements, so the size in which we have the greatest amongst all, we will choose our middle value over here. So 3 is our answer over here. Okay, so guys, now let's discuss the working of this solution. Okay, so let's get started. Suppose let's visualize this solution, and it will actually help you to remember this question, I think, for more than a year. So let's take 2 heaps, min heap and a max heap. And suppose I got a stream of integer where I have only one value, that is 1, right? So I can insert either in min heap or max heap, because both of these heaps are empty at this point. So suppose I insert this value in min heap, right? So I've already inserted. So now let's add another value, 1 and 0. So let's take a decision for 0 where to insert it. I think we can insert the 0 easily in the min heap. Okay, and now after inserting a 0 in the min heap, let's find the median of this problem, of this stream, right? So what would have been the median? As expected, we should get 0.5. So because both of these are equal, so so the string is of even length, the stream is of even length which we have got, and expected our output should be 0.5. So what would be our output in this case? Our output would have been an error. Why? Because as per the above assumption which we have took, we will basically take the middle values on the top of the heaps, right? But there isn't any value in this heap only. So how we will come to know where is a median, where is something like that? So it means we can't simply insert the values as it is in the min heap. So we need to take some decision accordingly, right? So at this point, since we already know that one of my heaps is empty, so I can insert this value in max heap. Okay, So fair enough, it's just for an assumption I have added, and now I will be simply calculate the top, simply find the top and calculate their averages, because size, both of their sizes are, size 1 is equal to size 2, right? Fair enough. So now let's insert one more element to the stream, that is 2, right? So let's make a decision where to insert this 2, either in min or in max. Both of their sizes are equal, and we know that we have to find a middle value. So what will I do? I will basically, so my sorted order would have been 0 1 2. Okay, so where could I actually insert? Either I can insert in max heap. So does it sound really good that if I insert in max heap? The answer is no, because at this point the maximum element would have been top, which is 2, and it would have created some problem for us, right? So I think 2 is not a preferred choice to insert in the max heap. So instead I will insert this 2 in the min heap, right? So till here the minimum element that I would get is 1, and since the sizes of both of these heaps are unequal, so what I will do, I will basically take the element, the top of that element which is greater in size, right? So in this case my min heap has a size greater than max heap. My size 1 is greater than size 2, so I will simply take my 1 as my median, right? Because at this point what has happened is we have correctly placed our 2 in the min heap. That's what my point is. So now let's move on to some other stream, and assuming I add 4 in it. So do you think at this point, so let's just make a sorted order in a rough column, 1 2 4. So what would my expected output be? 1.5, right? So now let's make a decision to add 4. So let's assume that I add my 4 in the max heap. Do you think it's a preferred choice to add 4 in the max heap? The answer is no, because at this point my top element would have been 4, whereas I have to keep my elements in such a way that the largest among the smallest is there on the top of the max heap, and the minimum amongst the largest is on the top of the min heap. So the minimum amongst the largest in this case is 2, and maximum amongst the smallest in this case is 1. Okay, so 4 is not my choice to insert in the max heap, so I will not insert it over here. So do you think that I can insert the 4 in the min heap? Right, I can insert easily. So, and I have inserted. Since we already know that we have even length of data stream, so what I will do, I will simply compute the top element, sum average of top elements. So 1 plus 0 divided by 2, it comes out to be 0.5. So my answer is wrong. So where my answer has actually gone wrong? So the presence of 1 in the min heap has made my answer wrong. Okay, so what I will do, I will simply, because we have to find the middle, so 1 is a value as per our order, as per our data stream, which should be at the middle. So I will simply remove this 1 from my min heap. I will insert it in the max heap, right? And now my status scenario of the heaps would have been changed. Two and 4. Okay. So what are the top elements at this point? 1 and 2. So 1 plus 2 divided by 2, it turns out to be 1.5. Okay. So now let's take one more last case, and afterwards I think the suspense would have been over. So I have, suppose 1, 2, 4 and 3, and at this point we already have the state of our heaps. So what do you think? Where should my 3 go? Because at this point both of my heaps are of equal size. So do you think we can insert it in the max heap? The answer is no, because at this point my 3 would have been the largest value. So do you think that we can insert it in the min heap? Yes, because the value 2 is at the top and it's the middle value amongst it's the smallest amongst the largest. So I can easily insert my 3 in this min heap. So what would have been my answer? The top of the largest, the top of the biggest size. So my answer would have been 2 in this case. And even if we sort this in increasing order, then also my answer would have been 2. So one thing which you all might have observed at this point, right? So whenever we have some odd length string, some odd length data stream, my size is never greater than 1. My size is never greater than 1. And whenever we took our size to be greater than 1, like the difference amongst the sizes. So what I'm trying to say, I've mistakenly said that the size is never greater than 1. So one thing you have observed in tests in third and fourth scenario, that whenever the difference of the sizes is the absolute difference of the sizes is greater than 1, I'm not able to find my median, right? And whenever my size is size 1 and size 2 difference is less than or equal to 1, I'm able to find my median. When it's equal, at this point I'm able to find my median, and whenever it's 1, I'm able to find my median at that point. So what we have to do in this algorithm while inserting the elements, we have to keep the track of the differences of the size of the two heaps. So we have to keep a track of this difference, size 1 and size 2. It should always be between 0 and 1. So that's what the algorithm basically states. And if you have understood this concept, you have understood the whole question. If you have not, then at this point I can only say to rewatch this whole clip of 9 to 10, maybe 8 or 9 minutes, and you will understand again. And if you don't, then try to dry run on the paper. Okay. So the major conclusion that I came at this point is that whenever we are inserting the elements in the heap, whenever we implement our addNum function, at that point we have to check the difference of the sizes. Like if it exceeds, then we have to remove the top element from the list and insert it in the opposite one. Like if I try to insert it in the, if my element is present in the min heap, then I have to pop it off and insert it in the max heap, right? And if my element is in the min heap, I have to pop it off and insert it in the max heap. So it means the difference among the sizes of both the heaps should always be between 0 and 1. Then only we are able to fetch the middle values. Okay. So fair enough. We had a good discussion over this. So now let's discuss the time complexity. So the time complexity earlier was n log n, which we have reduced to log n. because heaps are self-balancing structures, so we will basically reduce certain complexity. So they are basically inserting and deleting the value. So heaps basically insert and delete the values in log and time, and moreover our order of this list is also maintained, so it's a better complexity. And if we talk about the finding of median, it is also done in O of 1 time, because we are basically taking out the top values. Either we are doing their averages, or we are checking the size of the heaps, and the one which is larger, I will simply return their value. I'll simply return the top value of that heap. Okay. And the space complexity still remains O of n, because if we try to insert n elements, we have to store it somewhere. So we are storing these n elements at any point of time, even if we want, because this is the required space which we have to actually use. We can also say the space complexity to be O of 1, because we are not using any other extra space. So either if we store in heaps or in arrays, the thing remains same, that we are storing our elements in at some point. Okay, so now let's move to the code part of this question. So for this question I've already done the code, because one of my subscriber told me that it's taking a lot of time. Okay, so what I have done, I have taken two heaps, min heap and max heap, p1 and p2. So whenever I am adding my values, first of all I am checking that whether both of my heaps are empty or not. If both of them are empty, so I am simply assuming to push in my max heap, in my min heap, sorry. Okay, and whenever my first element is less than top of this min heap, so I will simply push my nums to that min heap, or else I will push it to num2. Okay, and in this condition what I'm checking that the size difference amongst the two is never greater than 1. If it exceeds, I will push the top of one of those, and I will pop one of the tops and I will insert in other. I think it's really confusing to say this. Like if the size of my min heap turns to be great, if the difference of the min heap size and the max heap size turns to be greater than, so this difference turns out to be greater than 1, I will simply pop my elements from the max heap. I'll simply pop my elements from the min heap and push it in the max heap. That's what I'm doing. And if my max heap size turns to be greater than 1 plus size of the min heap, what I will do, I will simply push the top element of my max heap in the min heap, and I'll simply pop that element from my max heap. And this is the code for finding the median. If both of my sizes are equal, I will simply sum average the tops, and if my max heap is min heap is greater, I will simply set the median value of the min heap's top, and else I'll simply set the value of max heap top. So I think this is a simple code, but to think up till this direction there were a lot of challenges. Okay, so let's just run this code, and now let's submit it. So the solution has worked effectively. So I hope guys that you have liked the way I have explained. If you haven't, then also, or if you feel that I've missed something, then you can simply type it in the comment section. I'm happy to improve myself. And if you really like it, please do like and subscribe my channel. It gives me a lot of support and a lot of motivation to make more videos like these. So thanks everyone for watching, and if you really like it and subscribe it, please do share it with your friends as much as possible, so that the network of this channel grows, right? So thanks everyone for watching the video.